So again, we're going to have a lot of vocabulary, a lot of definition, and because of the short time today, I'm not going to have examples to go through, so it's just going to be kind of straight notes, and you're going to have to use it and apply it to the work that you're going to do tonight. Okay. So we have two types of variables that we're going to discuss. The first type is qualitative. The root word of qualitative is quality. So there's going to be, if you want to think about it, because the next one I'll show you will make a little more sense. What we're using qualities to describe variables that can be placed into distinct categories, characteristics, or attributes. Examples are eye color. That's a quality. Whatever color your eyes are, that is a quality that you possess. Your religious affiliation, that is a quality that you possess. Okay? So again, think about it that way. Qualitative, the root word is quality. And again, we talk about variables, those can change. So from person to person in our own room, we have different eye colors. They have different qualities. At our school, we have different religious affiliations. Even though we have a lot of Catholic students, not everyone here is Catholic. Or teachers, for that matter. Anybody want to take a guess of what the other type of variable is? Yes? Quantitative. So the root word of quantitative is quantity. So what's a good way to describe quantitative? Numbers. Absolutely. It's good. Okay, quantitative is numerical variables. So quantities that are being discussed, when we're dealing with numbers, more often than not, we're talking about quantitative data. Quantitative variable. And there's a couple examples. I'm going to pick up the pace a little bit because we're down to about 10 minutes. Okay, so just keep that in mind. If you get to a place where you feel like I'm going too fast, I apologize now. Skip some space. You'll be able to go back to the video later, fill that back in. It is what it is today, I'm afraid. Okay? So there are also two types of quantitative variables. So within that quantitative variable category, we're going to break that into two categories. They are discrete, which means you can count. They can be counted. And there are, so the group of counted numbers are known as natural numbers. Okay. So just think if you're counting something. If you had a group of things and you wanted to figure out how many there were, you would count them. And there's no decimals, there's no fractions. That's sort of the key. Okay?
So numbers.
Natural numbers. You can count them. Meaning there's nothing in between each natural number. Now, sometimes they will give you a table that is decimal. So here's where there's the conflict. If they give you a list of numbers that are all the same decimal place, that could be considered discrete. Okay. It depends on how the data is represented. Now that being said, if you can't represent all the data, then that is continuous. Now I'm going to explain this in a way that's not written down, and I'm going to talk specifically about weight here in a minute after you write it down, so we'll talk about the difference. Here's the example I'll give, and I'll use the idea of weight. So this morning I woke up, and my scale, I don't know what it said, but I'm making this up, but let's say it said 205.6 pounds. That's how much I weighed, okay? And let's say today I decided I was going to have a, what do you call it when you're, a fasting day. Let's say I'm gonna have a fasting day today, and I'm trying to lose some weight today. It's not really healthy, but for the sake of the argument, I want to be 204.2 by the end of the day. Let's say I want to lose 1.4 pounds today. Is it possible at all for me to go from 205.6 immediately to 204.9? What has to happen before I get to 204.9?
You have to lose all the way in between.
Right. So I can't just magically teleport from 2056 to 2049. I have to lose incrementally along the way. So understand what the difference is. If I'm counting students, it's 1, 2, 3. It's not 1.1, 1.15, 1.16, 2 students. Okay? Discrete data has gaps in between the values, and it's okay. Continuous data can't have a gap. All the values in between have to also be included. There's no way to bypass some of the data in between the two data values that are given. Okay, does that make sense? Okay. Next, boundaries. Now this one's going to be a little bit confusing because there's not really a good way to explain it. I've done as best a job as I can, but I think it's better to actually see an example. And again, this is of continuous random variables. Because continuous, since there's no way to skip data values in between, or those measurements in between, what we do is we create boundaries of what the values could be. Because it's impossible, because so for example, how many values are there between, I don't know, 12 and 13? How many values are there between 12 and 13? Infinite. It's impossible to tell how many there are, right? So we create boundaries, right? So here's how that's going to do. And that's what this says. Continuous data must be measured. Answers have to be rounded. Because whatever we're using to measure has limits. Okay? Because of this idea of infinity. We have to pick a place where we're going to round. All right. Assume the number given from a continuous data set. So first you have to know it's continuous. Either they told you or you can tell by the description in the problem. But it's given to you in a rounded state already. And so when we create the boundaries, we take that number that they gave to us and we're gonna bound it. And so here's what you need to know, and again, it's going to be easier when I go through the example. They're given with one additional decimal place. So take the number you're given, you're going to increase it by one decimal place, and that digit that you're going to increase it by is going to be a 5, and you might have to change the number. So we can create boundaries around the given number. Like I said, I couldn't come up with a real good way to explain it, sort of with directions. When we look at the example, you'll be like, oh, I got it. Okay? So, here's the 3 examples. We're going to do A together. So that way we can see how to do it. And then you'll do B and C. So, here's the key. 73, the value they give us is 73. We have to assume that it's already been rounded, okay? Understand we're going to increase the number of decimal places by 1. So what happens is, I take 73, and now I start thinking about it sort of as 73.0. That's kind of the way I want to think about it. You're not going to actually write that. So you want to think of a number that has the 10th decimal place. What is the smallest number that rounds up to 73? That rounds up to 73 with a 10th of the decimal place. 72.5. That is my lower boundary. Okay, that is the smallest number with one decimal place that will round up to 73. Now, here's where we get into a little bit of a contradiction. Because one decimal place, what's the biggest number that rounds down to 73? 73.4. However, and again, this is where the contradiction comes into place. The reality is it's 73, and I don't know why they do this, I can't answer it, but we say it goes to 73.5. Even though we know it can't actually be 73.5 because if it was, it would round up to 74. So for the boundaries for 73, we go up all the way to the next digit. And part of that has to do with the definition because it ends with a 5 every time. This is the boundary for 73. Okay? So it's the same idea that you're going to do for B and C. Go down sort of to the next smallest one and then go up to the next biggest one.
What
Questions?
74 though?
No, it's always to one decimal place bigger than the number given. So since 73 is one decimal place, or there's no decimal place here, I go one decimal place beyond that. Yeah, I know it's a little confusing.
So then
Yeah.
would it be 74.5?
Nope. It's again, it's always 73 has to be right in the middle of those two numbers. Okay, and technically we should be thinking about it as 73.499999. That's the way it's almost 73.5, but it doesn't quite get there. But we bound it only one decimal place above. So if you change 73 to 74, now we've changed the whole number. We're only going a half a tick one direction or the other. That's the key. Maybe that's a better way to explain it. You're kind of going a half a tick one direction or the other from the number that you have. Now, from 3.8, what's half a tick down from that? 3.75. So I've increased the decimal place by 1. Let me get rid of this. Okay. So right. So this is 3.75, a half a tick down. And that's going to go to, what's the upper one going to be? 3.85. All right, do the last one yourself. What's the last one? What's the lower bound? 11.115. What's the upper bound? 11.125. How many had that? Okay. Does that make a little more sense? Like I said, the example, it helps to have the example. All right. So here's the part that I'm not going to get to. Okay. The measurement scales. I'm just going to throw this up there. There's 4 types of measurement scales. So what I need you to do before you try to do your homework, you need to read up on these 4 measurement scales: nominal level, ordinal level, interval level, ratio level. Okay? Now, that being said, this video that I'm creating right now still has all the different ones in it. Okay? And I'm going to keep going through it. So if you want to go back, maybe instead of reading it first, maybe you want to watch the rest of the video because the bell's going to ring. Okay? So there's nominal level, mutually exclusive categories, ordinal levels, putting things in order, you can rank them. The other 2, interval level, you put them in intervals, and then ratio level. So read up on that before you try to do your homework just to make sure you're good to go. Have a good day.